they found the first sign of intelligent life. It was a plastic bag. Think about that for a moment. 8 kilometers straight down. In total, crushing darkness. You are in the DSV limiting factor, a submersible built to visit the deepest points on Earth. You are explorer Victor Vescovo. The date is May 1st, 2019. Outside your tiny titanium sphere, the pressure is over 1,000 times greater than at the surface. It's enough to turn steel into powder. The mission logs released to the public detail the discovery of 4 new species of amphipods, a type of crustacean. But the official reports bury the lead. They don't emphasize what you saw first. Before the new life came the old trash, a simple, white, branded plastic bag. And here's the part nobody likes to talk about. This wasn't the first time. In 1998, the submarine Keiko found a plastic bag near the bottom of the Mariana Trench. We've known about this for over 2 decades. So why does the story always focus on the heroic explorer? Why isn't the headline, "We found our garbage in hell"? The submersible's lights cut through an eternal night. This is a place where sunlight has never reached. A place we assumed was pristine, untouched. You're watching the sonar, looking for movement. Anything that proves life can exist in this impossible environment. Your team spent years and over $48 million to get you to this exact spot. The goal was discovery, to push the boundaries of human knowledge, to find organisms that have evolved under pressures that should make life impossible. And you did. You found translucent snailfish and the ethereal spoonworm. But the very first thing you could identify, the first man-made object, was something you might see tangled in a tree back home. Think about the journey that bag took. It could have been dropped in the Philippines or California or Japan. It rode the currents for years, lay sinking. Down, 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 past the whales, past the giant squid, past the last rays of sunlight, into a world of alien biology and volcanic vents, an ambassador from our world to another. And what a message to send. What does it say about us? That our reach exceeds our responsibility, that even before we arrive in person, our waste gets there first. The mission continued, descending even deeper, eventually reaching the bottom of the Challenger Deep at 10,928 meters. But that image of the bag, it lingers. It reframes the entire expedition. It's no longer just a story of discovery. It's an audit, a receipt for our carelessness found in the last place you'd ever look. The team logged the bag's position and moved on, searching for life. But this single piece of plastic raised a far more disturbing question. If our most casual refuse can reach the deepest, most remote place on the planet, what else have we sent down into the dark? What else have we sent down is not something you can see. Not at first. It doesn't float past your viewport like a plastic bag. It's far more intimate than that. It's inside the bodies of the very creatures you came here to discover. It's a chemical soup, a toxic rain of compounds banned decades ago, still falling like an invisible snow through 7 miles of water. And it's in everything. In 2017, scientists from Newcastle University, led by Dr. Alan Jameson, published a report. They sent traps into the Mariana and Kermadec trenches, some of the deepest places on Earth. They didn't find just new species, they found polychlorinated biphenyls, or PCBs. These are industrial chemicals used in everything from electrical coolants to paint. They were banned in the United States back in 1979 for being dangerously toxic. And yet, here they were. The levels they found were not small. In the creatures of the Mariana Trench, the concentration of PCBs was 50 times higher than in crabs from one of the most polluted rivers in China. Read that sentence again. 50 times higher, in a place we thought was the definition of untouched. The official reports call these findings extraordinary. That's a polite, scientific word. A better word might be impossible or terrifying. How could this happen? The answer is simple and brutal. The ocean is not a collection of separate bodies of water. It is one, a single, connected system. And the deep sea is its final drain. For decades, we dumped our industrial waste into rivers and coastal waters, assuming it would dilute, disappear. But it didn't disappear. It simply sank. And here's the part that is rarely discussed. The very things that allow life to survive in the deep are what make our pollution so deadly there. The crushing pressure and extreme cold down, all chemical processes. It means these toxins don't break down. They just accumulate forever. It's a perfect chemical prison. But the prisoners are not the chemicals. It's the life that has to endure them. And it's not just PCBs. Mercury from burning coal finds its way into the sea, where bacteria convert it into methylmercury, a potent neurotoxin. It enters the food chain. A tiny shrimp eats some. A larger fish eats 100 of those shrimp. A squid eats 10 of those fish. By the time it reaches the top predators of the deep, the poison is magnified thousands of times. It's a process called biomagnification. Think of it like compound interest for poison, and it's a debt the entire ecosystem has to pay. The evidence is now overwhelming. One study published in Royal Society Open Science found that 72% of deep-sea crustaceans had synthetic fibers in their stomachs. 7 out of 10. These are not just bags and bottles. They are microscopic threads from our clothing, our carpets, our fishing nets. A constant abrasive blizzard of plastic settling on the ocean floor. But there is something else down there. Something heavier, something we were promised would stay sealed forever. Between 1946 and 1970, the United States alone dumped over 90,000 barrels of radioactive waste into the ocean. Many of them were dropped at a site just off the coast of California, near the Farallon Islands. The official documents assured the public the barrels were robust, that the pressure and cold would contain the waste for centuries. No one asked why they chose to dump it right on top of an active fault line. Today, surveys using robotic submersibles have filmed those barrels. They are not robust. They are corroded, leaking, their contents seeping into the deepest currents of the Pacific. We treated the abyss like a cosmic void, a perfect place to hide our sins. A dark closet for our most toxic secrets. But what if the abyss doesn't keep its secrets? What if it sends them back? It sends them back on your dinner plate. Think about that. The greatest return journey on Earth isn't a salmon fighting its way upstream. It's a molecule of PCB released from a leaking barrel 3,000 meters down, riding a biological elevator right into your kitchen. It happens every single night, in a migration so vast it can be seen from space. It's called the Deal vertical migration. Trillions of tiny creatures, from copepods to krill, rise from the depths to feed in the relative safety of darkness. Then, as dawn approaches, they sink back down into the abyss. They are the pump, the great circulatory system of the ocean. And they are pumping our poisons upwards. Here's how the ladder works. A deep-sea shrimp, living its life in the toxic sediment, consumes particles laced with methylmercury. That shrimp is eaten by a squid during its nightly ascent. That squid is then eaten by a tuna in the upper ocean. One tuna can eat thousands of squid over its lifetime. It's a process called biomagnification, a horrifying form of compound interest. The poison doesn't dilute, it concentrates, and the animals at the top of this ladder are the ones we prize the most. The Atlantic bluefin tuna, the swordfish. These are not coastal fish. They are titans of the open ocean, living for decades, growing to hundreds of kilos. They are also perfect sponges for mercury. The U.S. Food and Drug Administration sets the action level for mercury in fish at 1.0 parts per million. Yet, studies regularly find swordfish and tuna with levels far exceeding that limit. One analysis by the Mercury Policy Project found that 55% of tuna sushi samples from restaurants had mercury concentrations high enough to be unsafe for a woman of childbearing age to eat even once a week. And what does this poison do? In an adult, it can cause tremors, memory loss, and cognitive decline. In a developing fetus, it can disrupt the formation of the brain and nervous system. A silent, invisible legacy passed from one generation to the next. The official reports from governments are often confusing. They offer complex charts about which fish to eat, how often, and in what portion size. But nobody asks the simple question: why should we have to carry a risk calculator to the fish market? As coastal fisheries collapse from overexploitation, industrial fishing fleets have turned their attention downwards. They now deploy lines that are 100 kilometers long, with thousands of hooks, fishing deeper than ever before. They hunt in the twilight zone, the very region where the deep and the surface worlds meet, the place where the poison ladder delivers its payload. They market this catch as pure and wild, caught far from the polluted shores. And that's the greatest deception of all. The remoteness is exactly what makes them dangerous. They are swimming in the final reservoir of our industrial age. And it's not just the chemicals from the 1970s. Remember those 90,000 barrels of radioactive waste dumped off the coast of California? The ones we were told were secure? In 2011, after the Fukushima disaster, scientists began testing Pacific bluefin tuna. They found radioactive isotopes, specifically cesium-137. While much of it was traced to Fukushima, the baseline levels of radiation in the Pacific ecosystem were already elevated. The forgotten barrels, leaking for decades, had already given the ocean a low-grade fever. We treated the deep sea like a tomb, a place to bury things and never speak of them again. But it's not a tomb, it's a treasury, and we are now planning to plunder it. The same submersible technology that took Victor Vescovo to the bottom is now being used by corporations to map the seabed for minerals. Cobalt, manganese, nickel. The metals needed for our green revolution are sitting in vast fields on the abyssal plain, mixed in with the toxic sludge we put there. We went to the deepest part of the ocean looking for life. We found a plastic bag. We analyzed that life, and we found our own poisons inside it. And now, after everything we have learned, we are getting ready to go back down. This time with bulldozers. Ecosystem. They are a threat to people, to the scientists who have dedicated their lives to understanding this last dark frontier, and it is breaking them. Think about Dr. Alan Jameson. For over a decade, he has been one of the pioneers of Hadal science, the study of the deepest trenches. His team at Newcastle University and now at the University of Western Australia builds landers. These are not sleek submersibles. They are tough utilitarian machines designed to be thrown off the side of a ship and fall for hours into the crushing black. They are loaded with bait to attract creatures and cameras to see what answers the call. Imagine the feeling. You spend months, sometimes years, one of these. You sail for weeks to a precise spot in the middle of the Pacific. Yet you push a 400-kilogram piece of your life's work overboard, and you wait. For 8 hours, it sinks. Then it sits on the bottom of the world for a day. Then you send an acoustic signal, a tiny shout into the abyss, telling it to drop its ballast and come home. And you wait again, hoping it rises, hoping you can find it in the vastness of the ocean. And when you finally get it back on deck, your hands shaking from adrenaline and cold, you pull out the memory card. This is the moment of discovery, the first human eyes to ever see what lives at the bottom of the Kermadec Trench. But what do you see? You see tiny crustaceans, amphipods, swarming the bait. Life, triumphant. But when you get them back to the lab, the triumph turns to ash. You find their bodies are saturated with industrial poisons banned before you were born. And you find their guts are full of plastic fibers from clothing. Jameson himself has described the feeling. It's not excitement. It's a profound sadness. He once said, "The punchline is, every time I go to the deep sea, I find that it's been contaminated by us. Every single time." There is no discovery without disappointment. The official scientific papers don't have a section for the emotional toll. There's no metric for the grief of finding a world already in mourning. But why is no one asking what this does to a person? To spend your life searching for wonder, only to become a bookkeeper of our own destruction. Or think of Victor Vescovo, a millionaire adventurer funding these expeditions himself. He is often portrayed as a hero, a modern-day Magellan. The official record of his 2019 dive lists the 4 new species he helped identify. It doesn't list what he said he felt when he saw that plastic bag. Disappointment. That was his word. He said it was not a big surprise. Think about that sentence. The man who went to the most inaccessible place on Earth was not surprised to find our garbage waiting for him. We have robbed our own explorers of the capacity for shock. All that is left is a weary, predictable disappointment, a quiet audit of a crime scene. These scientists and explorers are our canaries in the coal mine, and they are not singing. They are choking. And the part nobody wants to admit? Their work, the very research that reveals this horror, is now being used to justify the next phase of destruction. The geological maps they create to understand life are the same maps mining corporations use to find cobalt. Well, the message we are sending them is clear. Thank you for showing us where the last pristine places are. Now please step aside so we can tear them apart. The metals they want from that seabed are not for some abstract industry. They are destined for the battery inside the device you are using to watch this, right now. It connects you to this story in a way that is deeply uncomfortable. The demand for the cobalt and nickel inside its battery is projected to increase by over 500% by the year 2050. And the easiest place to find it is at the bottom of the sea. Think about what that means. We have created a problem, our climate crisis, and our proposed solution is to create another one. Here's the part that is rarely discussed. This isn't some distant hypothetical. The plans are being drawn up right now. The body responsible for writing the rules is called the International Seabed Authority, or ISA. It's a UN-mandated organization based in Jamaica. Their job is to manage the mineral resources of the deep sea, which are legally considered the common heritage of mankind. But they have two jobs. And the second one is to ensure the protection of the marine environment. How can you serve two masters? How can you be the promoter of an industry and also its watchdog? The target is a vast abyssal plain in the Pacific Ocean called the Clarion-Clipperton Zone. It's an area roughly the size of the contiguous United States, and the ISA has already issued over 30 exploration licenses, carving up this dark world into a grid of future mining claims. But wait, that's not the whole story. For the first time, there is resistance. As of 2023, more than 20 countries, including Germany, France, Spain, and Chile, have called for a moratorium, a pause. They are asking a simple question: how can we approve the destruction of an ecosystem we do not even remotely understand? If we know more about the surface of Mars than we do about the floor of our own ocean, and this is where it gets interesting. The argument for mining is an argument of necessity. They say we need these metals for a green transition, but nobody mentions the alternatives. Improving battery recycling technology. Designing products that use less of these rare metals in the first place. This isn't a choice between a green future and a protected ocean. That is a false dilemma. It's a choice between the difficult work of innovation and the easy, brutal work of extraction. The plastic bag Victor Vescovo found was a record of our thoughtlessness. The PCBs in the bodies of deep-sea creatures are a record of our ignorance. But scraping the seabed clean with robotic bulldozers? That will be different. That will be a record of a choice, made with full knowledge of the consequences.